physics. So in previous lecture, we study about the magnetic field of lines. So what are the magnetic field of lines? So first of all, we make a figure. So this is a magnet. So this magnet consists two poles. This is north and this is south. So this magnet consists two poles, and these two poles name what is north and south. So what are the pattern of a magnetic field here? So magnetic field of line start from north pole. So these are like so these field lines are start from the north pole and merge at the south pole. So direction of these lines are what? From north to south. And inside the magnet, direction of a magnetic lines of force from north to south. So here what is important? Outside the magnet, direction of lines from north to south, and inside the magnet, what are direction from north to south. So there are many lines are present, like so these lines are shown as, so this is the complete diagram of a magnetic field of lines due to a magnet. So what is this is due to a magnet. So here what are important points? So what are important points? First, so first what is direction. So direction from north to south outside the magnet. So this is first point, and second point inside the magnet. So inside the magnet, what is direction? North to south. Inside the magnet, direction north to south. And third thing here, what is? These lines are more crowded at the ends. So here at the ends or a poles, these are more crowded, or we can say that intensity of the magnetic field is high at the south pole and north pole as compared to center point. So intensity of lines is greater at poles, And another things here, so these are the important points. And another things what we can find out direction of a magnetic field. So how to find out direction of a magnetic field? Take here tangent. For example, this is a lines. So select point here. So here we select point P. So this is a point P, and draw here tangent. So if we draw tangent here, this is the direction of a magnetic field. For example, another, for example, we take another lines and take point, we take 3 point. For example, this is point P, and this is point Q, and this is point D. So we have to find out direction of a magnetic field here. So we have to find magnetic field direction here and here. So taking point, draw tangent here. So this is tangent. So direction of a magnetic field this. So B is magnetic field and gives the direction. If we draw tangent here, so this is tangent and this gives the direction of a magnetic field. Another point like this, here if we draw tangent, so this is the direction of a magnetic field. So these are the important property of the magnetic field, and this concept is purely imaginary. Imaginary means these are invisible, so we only make imaginary concept. There are some lines, and these lines are shown by the magnetic field. So next topic, what is magnetic field inside the current carrying loops. So in next, what is magnetic field due to a current carrying loop of wire. So for this we take a wire, and this wire in the form of a circle. So for example, so this is a wire of metal. So if we apply voltage here, for example, we apply here voltage, for example 10 volt. So what happened? Current flowing in the wire. So how current flowing? Current always flowing positive to negative direction. So direction of a current this. So this shows the direction of a current. So here we can find out direction of a magnetic field. So how to find out direction of a magnetic field? Direction of a magnetic field find out by the right hand thumb rule. So direction of magnetic field can be found using right hand thumb rule. So if we take here right hand thumb rule, so according to this is right hand thumb rule, so align your thumbs in the direction of a current. So we align our thumbs in the direction of a current and wrap your finger. So if we wrap your finger, then wrap fingers give the direction of a magnetic field. So here what is? Here circle of the magnetic field form. These are known as the concentric circles. So there are many circles like this. And what is the direction of these circles? So like this. So that is anticlockwise. So what is the direction of a here magnetic field? Anticlockwise and perpendicular to the board. So here, for example, direction of a current here like this. So if we align our thumbs in direction of a current and wrap your finger, then we find out direction of a magnetic field this. So if we increase magnetic field, so what happen? Then lines of a magnetic field increase, and at the center these lines are uniform. So magnetic field or a magnetic field of lines in the circle are uniform, and at the center, like this is a center, and at center what is, these are straight line. So this is magnetic field due to the current carrying loop. So next we study about the solenoid. So solenoid is the application of a current carrying loop. So if we bend many coils into a many circular loop, so that is known as solenoid. So basically, what is solenoid? This is a wire which bent in the form of many circles around the insulated materials. So this is a solenoid. So basically, so structure of a solenoid like this. So this is a copper wire, for example. Copper wire consists many turn. So this is the example of a solenoid. So when we connected a voltage here, so what happened? Electric current produced, and whenever electric current produced in a wire, then it produced magnetic field. So for example, we apply here voltage. So what happened? If we apply voltage here, then electric current flowing into the wire, and these direction of these current what is clockwise. So we already know when electric current flowing into a wire, then it produces magnetic field. So here every circular loop, produce magnetic field, and these magnetic field produced by each loops are added. So for example here, how many loops? This is first loop, this is second, third, 4, 5, 6. So here how many loops? 6 loops. So magnetic field produced are added due to each loop. For example, here magnetic field produced by one loop, 1 Tesla. So Tesla is the unit of a magnetic field. For example, here how many turns? 6 turns. So here magnetic field is 6 times. So how much? Here 6 Tesla. So simply we can say that magnetic field depend upon the number of a turn. So if we increase the number of a turn, then magnetic field also increase. Second, we already know magnetic field depend upon the amount of current. So when we increase the amount of current, then magnetic field also increase, and amount of current depend upon the voltage. So when we increase the voltage, current increase, and current increase, magnetic field increase. And second alternate example, what is number of turn? So if we increase number of pattern, then magnetic field increase. So here, what type of pattern form? So here, what type of pattern form? For example, these are lines of a magnetic field. So this is the pattern of the magnetic field due to the solenoid. So here we study about the magnetic field pattern due to the magnet, and second, what is solenoid. So here question, which end of the solenoid is north pole and which end is south pole. So here this pole act as a what is south pole, and this act as a north pole. So this pattern is similar to the simple magnet. So this solenoid can be used to make a magnetic material. So if we change, for example, if we change here voltage, so we change the polarity, this is negative and this is positive. So what happens? Then direction of the current is reverse. So if direction of a current is reverse, for example, direction of current, this is positive, this is negative, direction of a current reverse. So what happens? This act as a north pole and this act as a south pole. So this already changed. So direction is reverse like this. So polarity of the north pole and south pole depending upon the terminals of the voltage or a polarity of the voltage. So here basically magnetic field is directly proportional to the amount of current, to first amount of current, and second amount of current, and second number of turn. Number of turn. So we can write B is what is magnetic field. Directly proportional to I and N. So I is current and N is number of turn. And we can write in the form of a formula, B is equal to mu naught Ni. So here what is mu naught? So mu naught is what is? Mu naught is the magnetic permittivity of the material, which allow the magnetic lines into the space, or we can use any other material. So these are the magnetic field produced by the solenoid, and these are the formula of a magnetic field which depend upon the number of turn and current. And secondly, what are the application of a magnetic field? So application of a magnetic field. So most important application of a solenoid to make a electromagnet. To make a electromagnet. So how we make electromagnet? You take a material like nickel, chromium, cobalt and iron. So these are the symbol of a metals: nickel, chromium, cobalt and iron. So these materials put into the solenoid, and what happens if we put these solenoid and we put these material into the solenoid, like these are the materials. For example, this is a cobalt. So what happens when we switch on? When we switch on, then electric current flow, and electric current flow, then magnetic field produced, and these magnetic field pass into the materials. So these magnetic field produced by the solenoid make electromagnet. So how much these material make a magnet? So this is depending upon the how much magnetic field lines passing through the material. So most common application of a solenoid to make a strong electromagnet, which are used in many communication device, transmitter and the other like speakers. So this is the most common application of a solenoid. So next is force. Force act on a conductor due to magnetic field. So this means when we put a conductor inside the magnetic fields, what happens? Then magnetic field apply force on a conductor. So for example, this is a magnetic field. And this is a conductor. So when we place a conductor in a magnetic field, what happens? These magnetic field apply force on a conductor. So these depend upon the polarity of the magnetic field. Second, depend upon the angle. For example, this is the angle. This angle known as the theta, and this angle between what is magnetic field B, and this is what is length. So this known as the length of the conductor L. So when we place a conductor in a magnetic field, then it experiences a force due to magnetic field. So next, like force experienced by the charged particle in magnetic field and other application we learn in next lecture. So thank you very much. If you have any query, then you put your suggestions or a question in comment box. Thank you very much.